Hi everyone and welcome back. So we're going to focus more on Chapter 12 on problem solving and reasoning. So we're going to pick up here and start out with talking about Wolfgang Kohler's work on problem solving with chimps. So Wolfgang Kohler was actually a German Gestaltist psychologist, and during World War II he was actually on the island of Tenerife. And he initially set out to study visual perception in chimpanzees on the island, but over time he became more interested in studying problem-solving behavior in chimps. And he was actually the first one to come up with the theory of insight into problem solving that he observed in those chimps. So Kohler actually had a prize chimp, which he named Sultan. So he is actually pictured in the picture that you can see on the screen. But he also, of course, had other chimps that he observed while they were trying to solve problems. So he actually presented them with a variety of different problems. As you can see here on the left, he put them in an enclosure and he hung these different bananas, so a reward for them, high up that they couldn't reach it. Initially, the chimps would try to run around in the enclosure and jump up and try to reach them, but it was always too high for them to reach. So then as a next step, they tried to find different objects around the enclosure, and eventually they figured out if they stacked up the boxes, they could actually climb up and reach them. Similarly, on the right, you see how the chimp here actually had to put together two poles for it to be tall enough so he could reach a really high up stack of bananas. And again, right, these were all novel problems for the chimps, but they were really amazing at figuring out, obviously the goal was to reach the bananas, and then they overcame the obstacles that Kohler put in their way, right? In this case, that the bananas were too high up to reach, but they always managed to find a solution and to overcome the obstacles. So let's watch a video on something similar. This is not obviously Wolfgang Kohler's chimps, but a different animal here that we can observe trying to solve a problem.
I was absolutely panicked, wondering how I was going to get to treatment.
At the Max Planck Institute for Evolutionary Anthropology in Leipzig, Germany, psychologist Joseph Cole places a peanut inside a clear tube. How can the chimpanzee get the snack? She's never seen this puzzle before.
For 10 minutes, there is no solution in sight. And all of a sudden, boom, they solve it. They have to understand that they can use the water as a tool. This is interesting because the water itself, it doesn't have any shape.
Using water as a tool seems like something we would do on a good day.
So as you could see in the video, right, very smart chimp was able to figure out that he or she could use the water so the nut would eventually rise to the top of the beaker so they could grab it, right? So that's actually very smart. All right, so this leads us to basically the theory that Wolfgang Kohler came up with as a result. So he was the first one that actually came up with this idea of this theory on insight. So this was the first cognitive theory of learning at the time, and he called it insight learning. So insight learning is really this sudden realization of a problem solution. And a lot of times the process is, right, similar to what I was describing with the chimps, that at first, right, the animals would see the bananas and, their typical solution that they get bananas and they can reach them, right, would not work. So, initially they would try what they had done in the past to overcome obstacles, right, jumping, trying to reach for them. things like that. And then usually it also, there's usually a period where they get really frustrated because their typical ways to solve the problem, they are not working, and then they have to come up with something else. So it seems that problems like this sometimes require some restructuring of the problem. So you have to think outside the box. Maybe your routine solutions to problems is not working, so you have to really think about it in a different way and come up with a new way to solve the problem. And then, right, you see the light bulb in the picture, right? That's when you have this sudden insight. And something that's unique about these types of problems is that the insight comes on very suddenly. So you have this eureka moment of, oh, that's the solution. Truth be told is that those things don't typically happen really all that suddenly, but that's how it feels, right? You have this aha moment all of a sudden. But as you will learn later on, right, it actually does require a decent amount of knowledge about the world and how things work to typically solve these things. So even though it seems very sudden, your mind is actually getting closer and closer, even you might not be aware of that. So there's different kinds of problems, right? There's insight problems and then there's non-insight problems. So insight problems would be similar to the problems described over on the right. So these were also in the book. So there's the triangle problem where you have to rearrange the dots, and then there's also the chain problem that you can find in your textbook on page 367. So try to solve those if you want to. So those are examples of insight problems where it's probably going to take you some time, similar to the piggy problem with the pens, but to come up with a solution. An example of a non-insight problem would be algebra. Most of the time, right, when you're trying to calculate a t-test or a regression, right, you don't have an aha moment and you're solving it. Usually it's a slow but steady progress towards a solution. So Metcalf and Wiebe actually designed a study where they wanted to look at the process of solving these different kinds of problems. So in their methodology, they gave people different kinds of problems, and they asked them every 15 seconds to give them a judgment of warmth of how close they actually thought they were getting closer to the solution of the problem. So you probably remember that, right? Maybe blindfolding somebody is like, oh, closer, warmer, kind of thing. So they had to give an estimation of how close they were to the solution of the problem. So in this graph, you can see on the x-axis the time before the solution was found. So that would be measured in seconds. And then on the y-axis, you see the median warmth rating ranging from 0, so you're really far away from the solution, you have no idea, to 7, where you actually solve the problem. So what's really interesting here is when you look at the blue dotted line, right, for an algebraic problem, it's actually pretty gradual, right, uptake, right? You are presented with a problem, it takes you a second to orient yourself, and then you very gradually work towards the solution of the problem. The trajectory is a little bit different for the insight problem, marked in red here. So you can see that it stays flat for about the first 30 seconds, and then actually all of a sudden, right, it goes up, whoop, you think I'm on the right track, and then boom, you reach the solution. So with an algebra problem, right, which is a non-insight problem, it's a very gradual and steady process, whereas with the insight problem, usually you have this flat line of you're not getting anywhere, and then all of a sudden, you reach your solution, you have that aha moment. Another example of problem solving would be that a lot of times when we're trying to solve problems, we really have to think outside the box, and that's not always easy. So an example here is functional fixedness. So functional fixedness is the idea that you're restricting yourself to thinking about an object in a very specific way that you're familiar with. So for instance, when you think of a book, you think about it in terms of using it for reading, but you could also use it, right, to cover yourself from the rain. You could use it as a coffee table, or you could use it as to keep a door open, for instance. So there's different uses there. But in your book, they actually have two problems: the candle problem and the two-string problem. So for the candle problem, you would be given 3 candles, you would be given a matchbox with matches in it and some tacks. And then your goal would be to actually build a little sconce for the candle. So you would have to use those objects to hang the candle on the wall. So try to think about that, look at the book, see if you can find the solution. And then the 2-string problem is a little bit more complicated. I actually have a video that I will link on Blackboard that you can actually watch. It's quite interesting. So they actually did this experiment at a university, and they filmed college-age students that were faced with this challenge, and how they actually, a lot of times you can see it was kind of an inside problem, right? Some of the people weren't able to actually get to the solution, but some were, and it's really interesting how they actually get to it, right? A lot of it is trial and error, but it's kind of fun to watch how people actually reach that. So functional fixedness in general is kind of this mental set where you use previous knowledge or experience to define an object, and sometimes actually your previous knowledge, so that would be using a top-down process, which we discussed earlier in the semester, can kind of get in the way of you really thinking outside the box. So a lot of times we fail to think about an object in other ways that maybe we could use that. Another example of that would be, you get in this mental rut, which is kind of the same process as I was just describing. So you basically think about problems in only one way. So you're very fixed in that way. But if you're faced with a problem, right, that it's not working for, then you need to think outside the box and you need to change your approach. Being, having this mental set, you're very set in a certain way of thinking that doesn't allow you to really come to or to use a different strategy to think about problems. So, if you think about, different objects and how you use them, but usually it's pretty clear. Take, for instance, a hair dryer, right? I mean, you can obviously use a hair dryer, as the name would imply, to dry your hair. But you could also potentially use it, as a, to blow your leaves. I would not recommend that, but you could potentially do that. You can think about your toothpaste container. You could think about that as a little container. You could make a little, you could poke a hole in the top and then actually stand your toothbrushes in it and make it a little stand. So there's different objects, right, that we think about in a very specific way, but, a lot of times there's other things that we could do with those objects. And research has actually shown that functional fixedness is greatest for objects that we're very familiar with. So if they're very familiar to us, so we think about them in a very specific way, that makes it even more difficult to overcome functional fixedness. And this is, of course, an example of a top-down process where, we have learned to use certain things in certain ways, and as a result, right, that prevents us from thinking about them in more original ways. And I will say that, especially if you've ever worked with kids, right, you really see how they're so much more creative in thinking about objects in different ways, right? I see this with my kids all of the time, that they see a container of something and, they make it a little house. So they usually are not as prone to functional fixedness as adults are, because they're not as fixed in their ways of thinking about certain objects. So, maybe you can think of some of your own examples of how, you could find different ways to use different objects in other ways. To give you one example, when I was in college, I did not bring a hammer with me, but I wanted to hang a picture. So actually, I used a glass bottle to hammer a nail into the wall. Right? And, I may have not thought about that, but, it was kind of the only object that I had around that kind of resembled something that I could use to hammer a nail into the wall. So that's an example where I overcame functional fixedness to solve a problem because I didn't have what I actually needed. Okay, so I'm going to stop here and we're going to continue on in the next video.